Hello, my name is David Viennes. I'm Vice President for Business Development for FLIR's Unmanned Systems and Integrated Solutions. I want to welcome everyone to this webinar on making robotic vehicles smarter with FLIR's AI-enabled sensors and unmanned systems. First, I want to thank AUSA for this opportunity to present. I want to thank everyone for your time today. And most importantly, as a retired soldier, I want to thank our soldiers for what you do every day for our great Army and our great nation. FLIR Systems provides leading-edge dual-use sensor technology, including EO/IR surveillance, aided target recognition, unmanned systems, and chemical biological detection to meet the demands of our warfighters and Army Futures Command's cross-functional teams' modernization priorities. FLIR, as part of the Textron Systems and How team, as part of the effort, create a smart robotic vehicle for the Army called the Ripsaw M5, which you see in this image. At FLIR, we like to say we don't make the ripsaw, we make the ripsaw smarter. Our technology is a real game changer for the Army, setting the Ripsaw M5 apart from other robotic vehicles by providing a great mix of AI-enabled sensors and unmanned systems for complete situational awareness, protecting the vehicle close in and providing long-distance threat standoff. We believe that the Ripsaw M5 extreme mobility vehicle, combined with FLIR's intelligent sensing technology, is going to revolutionize the future battlefield. So as you can see in this image, FLIR incorporates a number of sensors to the M5. So specifically in this presentation, I will discuss the FLIR R80D Skyraider UAS, FLIR's Summit 360 system for 360-degree situational awareness around the vehicle, FLIR's 280 HD EO/IR gimbal, and finally FLIR's Marsupial unmanned ground vehicle. These integrated multi-domain and intelligence solutions provide increased soldier lethality, greater threat standoff, and they lower the soldier's cognitive burden. So let's move on now to the individual sensor overview. The first capability I'll discuss is FLIR's R80D Skyraider UAS. This is a mature platform that's being used currently by all U.S. DoD services. With a number of sensing payload options, the R80D delivers actionable intelligence, increased standoff of the enemy, and faster target detection, classification, and tracking through its onboard neural network. And I'll show you some of those on the next video. It's configurable between tethered and untethered modes, enabling a user to decide how to best use a system based on mission needs. So this means, for example, that I can keep it attached to the Ripsaw M5 and fly it in a tethered mode for persistent surveillance in excess of 24 hours, or I can disconnect it from the tether and free fly it to investigate targets in depth. I think this would be useful if the threat moves into an area that cannot be observed from a stationary sensor. I mentioned on the last slide that the R80D provides autonomous target detection, classification, and tracking through its onboard neural networks. So as you can see in this video, the aircraft classifies and automatically tracks multiple moving targets simultaneously. We identify personnel and vehicles with different colored boxes as shown here. We also provide moving target indication, which is the green box that track the targets. Classification feature and moving target indication unburdens the operator's workload through autonomous selection. Additionally, the system provides real-time calculation of the heading, speed, and magnetic grid reference value for the target that is selected for tracking. So let's move on now to a discussion about the Summit 360 system. Close into the Ripsaw, we use 4 Summit 360 modules for seamless daytime and nighttime 360-degree situational awareness around the vehicle. Each module is comprised of EO and IR cameras for complete coverage of the sector, and we cover the entire area around the vehicle with 4 modules, one on each side. This system is based on mature technology used in safety-critical advanced driver assistance systems, or ADAS. The imagery from all of these cameras is seamlessly stitched together to form a panoramic view around the vehicle. This capability helps with not only remotely driving the vehicle, but the built-in artificial intelligence helps the operator detect and identify both friendly and threat objects nearby, to include obstacle detection. In this video, you see an example of the stitched imagery from one Summit 360 module. The AI-enabled system allows remote operators to detect, identify, and track threats day and night, reducing soldier cognitive load. Our AI is not only able to identify a person, but also classifies the person as military or civilian and armed or unarmed. Operationally, you can see how this would be a critical capability to identify nearby threats, but also to avoid friendly fire or civilian casualties. Now let's discuss the tremendous standoff and capabilities of the FLIR 280HD. The stabilized 280HD gimbal provides a critical capability when we talk about layered standoff. It can be configured with a number of payloads to include color low light, mid-wave IR, short-wave IR, a laser rangefinder, and a laser pointer. It really allows operators to reach out and positively identify threats at thousands of meters using high-power video processing and built-in AI, reaching out even further than even the tethered UAS. Its built-in laser rangefinder determines range of target and geolocation for fire control calculations. Much like we showed with the Summit 360 SA system at close range, the FLIR 280 is able to reach out thousands of meters and detect, classify, recognize, and identify both friendly and enemy personnel and vehicles. Again, the military utility of this cannot be understated. Not only does this reduce soldier cognitive load, but it speeds the decision-making process for the warfighter, increasing his chances of success. And at the end of the day, it helps decrease the risk of friendly fire or civilian casualties. Lastly, let's discuss the SUGV robot payload. The SUGV has been in use for years by the US and allied militaries for things like conducting remote surveillance to use by EOD elements to investigate hazardous devices. For the robotic vehicle program, we integrated it to the RIPSI M5 as a marsupial payload through its unique deployment mechanism on the front of the vehicle, where it remains ready to deploy at all times. It provides another level of standoff and early warning to the M5. It can be used in any number of ways, from route reconnaissance, for example, to investigate a possible IED threat, to target interrogation. The SUGV is also highly mobile and rugged for use in all environments. It is able to climb stairs and over rubble, manipulate objects for greater inspection, and investigate areas and objects using its built-in cameras. It also includes mesh network radios to extend its range in complex environments, such as dense urban areas and subterranean areas. So that was a brief overview of how FLIR is making robotic vehicles smarter with AI-enabled sensors and unmanned systems. I hope this was interesting and informative to everyone that attended. I cannot overstate how proud we are to be working on this project with Textron and How as part of Team RIPSA, and how focused we are in making this a success. I truly believe, as a soldier, that we are creating here is revolutionary for the Army. It is going to save lives on the battlefield, something that is very, very important to us. Thank you for your time, and I look forward to your questions.